Good morning. I normally check the volume on my mic every time I record a video. It looks like the volume is not working on the original version of this, so we will make sure it's working this time before submitting it. So this lesson, or today's lesson, is going to talk about lesson 8.4's guided notes on the volume of prisms. So there's quite a few formulas we're going to talk about here. There's one major formula, and then we're going to kind of break it down into two different versions, and we'll talk about several different types of prisms. Before we do that, let's talk a little bit about what volume is. So we've already talked about perimeter and circumference. We've talked about area. When we talk about volume, we're looking at three-dimensional shapes, which we worked on last unit. When we talk about volume, we're measuring the space inside of a three-dimensional figure, kind of like area, but for a three-dimensional shape. So if you're going to be filling up a pool with water, we're looking at volume. When we're trying to figure out how much of some sort of ingredient to include in a recipe, we're looking at volume. So we're only talking about volume of prisms in this lesson, although there are several different types of prisms that we'll deal with. The basic formula for the volume of any prism is going to be the area of the base times the height. So we use capital V for volume equals capital B times H. Now I want to stress that capital B is different than lowercase b. There are times in math where an uppercase versus a lowercase letter does matter, just like it does in English. Capital B references the area of the base, whereas lowercase b just stands for the length of the base. So those are two different things. So when we say capital B, we're talking about the area of whatever the base is. So if that's a rectangular prism, those would be a rectangle, the bases. Triangular prism, the bases would be triangles. Hexagonal prism, the bases would be hexagons. So when we talk about capital B, that represents the area of the base. Now, there's essentially two different shapes we're going to be looking at, although the second one, the polygonal prism, is broken down into a lot of different shapes. But the first is going to be a rectangular prism. If I'm asked to find the volume of a rectangular prism, and this is on your formula sheet, we want to use the formula capital V equals L times W times H, length times width times height. You just multiply all of the dimensions. It really is area of the base times the height, since the area of the base, which happens to be this rectangle here and has dimensions length times width, we would find the area of the base to be length times width, multiply it by the height of this prism. So that's why this makes sense. Really, any prism is going to be area of the base times the height. Now on your formula sheet, you'll also see this picture. For a polygonal prism, we use the formula capital V equals capital B times W, the area of the base times the width. So the formula sheet, PSSA decided to use W instead of H, W representing the width of the prism. We can also call it the height of the prism. It's also the distance between the two parallel bases as well. Use this formula for any prism that is not a rectangular prism. That includes triangular prisms, pentagonal prisms, octagonal prisms. But you can use it for any shape that's not a rectangular prism. Technically, you can use it for a rectangular prism. This formula is a lot simpler though. You may want to pause the video at this point and think for a moment what you think the formula is for the volume of a cube where every edge has length s. All right, so to find the volume of a cube, what we're going to do is we're going to do s to the third power. Because if we do length times width times height, and the length, width, and height are all s, it's s times s times s, or s to the third power. That may be on your formula sheet. You may want to look and see if it is. If not, it's in your guided notes. All right, let's move on to our examples. So the first three examples, 1, 2, and 3, are going to be really simple. We're looking at rectangular prisms or boxes. So in number 1, if I want to find the volume of this rectangular prism, I'm going to do length times width times height. It does not matter which one is length, width, or height. I'm just going to multiply 4 times 3 times 6, which is going to get me 72 centimeters cubed. Now note the label here. When we talk about volume, it's always going to be meters, feet, inches, miles, whatever, to the third power or cubed. Kind of like area for volume, when we say centimeters cubed, it's telling me that I can fit 72 cubes that are 1 centimeter on each side inside of this rectangular prism. So we could fit 72 cubes inside of here. Number 2 happens to be a cube. So we can either do length times width times height, or we can do s to the third power. S is 2.5. Take 2.5 to the third power. If you don't know where your exponent key is on your calculator, this is something you can always check in with me about. But you can also just do 2.5 times 2.5 times 2.5. Now at this point, you may want to try number 3. Pause the video, give it a try. We'll go through the work in a moment. All right, so number 3, this is also a rectangular prism. So we do length times width times height. We're going to take 6 times 1.9 times 10, does not matter which order they go in, and we will get 114 millimeters cubed. Now, before we get into 4, 5, and 6, which are triangular prisms, I did type up an example for you. So this is a triangular prism. And if we have any prism that is not a rectangular prism, we want to use the formula capital V equals area of the base times the width. Now, the base of this triangular prism, we actually have 2 of them. They're triangles. So we need to find the area of the base. And the formula for the area of a triangle, since it's a triangular base, is half times base times height. So in order to find capital B, area of the base, we do half times lowercase b, which represents the base of the triangular base, times the height, which is the height of the triangular base. So remember that base and height have to intersect at a right angle or 90-degree angle. We see that right here. So that means the base and height of the triangular base will be 4.1 and 3.2. So we do half times 3.2 times 4.1 to get an area of the base of 6.56 inches squared. Again, that's for the area of the base. I don't need to use the 5.2 inches since it's not the base or height of the triangular base. So I'm going to replace capital B with 6.56. Now W is the width of the prism. That's the distance between your 2 triangular bases, which in this case will be 8 inches. So we'll take 6.56 times 8 to get a volume of 52.48 inches cubed. Let's try another example. So number 4, this is a triangular prism. And the very first thing that I need to do here is I need to find the area of the base. Let me make sure I erase the right one here. So the base happens to be a triangle. I'll highlight that in yellow here. So this is our base, as is this guy back here. But the base and height of your triangular base will intersect at a 90-degree angle. So those will be 9.8 and 5. So we'll do half times 9.8 times 5 to get an area of the base of 24.5 meters squared. Notice since it's an area, I'm using meters squared. For my final solution for volume, I will use meters cubed. Now, when we go to find the volume of this thing, we're going to do area of the base times the width. The width of this prism is the distance between your 2 triangular bases, which will be 4. I do not need to use the 11 at all, but I'm going to take 24.5 area of the base times the width, which is 4, to get 98 meters cubed. All right, let's take a look at number 5. So for question number 5, we also have a triangular prism. Let's start by finding the area of the base, which again will be a triangle. I'll highlight this guy in yellow. This is going to be a triangular base. Remember, the base doesn't have to be what it's sitting on. If it's a triangular prism, that base is a triangle. The base and height will be 26 and 28 since they intersect at a right angle. Half times 26 times 28 gives me an area of the base of 364 meters squared. To find the volume, we take area of the base and multiply it by the width. The width of this guy is going to be the distance between your 2 triangular bases, which will be 41 meters. So we'll do 364 times 41 to get a volume of 14,924 meters cubed. Again, at this point, you may want to pause the video and take a look at number 6 on your own. Maybe give that problem a try. This is another triangular prism. So our bases are the two triangles. So this guy right here, and then this guy back here. So to find the area of the base, we do half times base times height. We see a right angle right here to tell us that the base and height of the triangular base are 8 and 4. Half times 8 times 4 gets us an area of the base of 16. When we go to find the volume, we are going to do area of the base, which is 16, times the width, which is the distance between your two triangular bases. That will be 15. 16 times 15 gets us a volume of 240 centimeters cubed. All right, let's take a look at numbers 7 and 8, our last two problems. These are actually easier than the previous ones, as you might be able to tell from the smaller boxes here. But this happens to be an octagonal prism, so we're still going to use volume equals capital B times W. Capital B in this case is the area of the base, and they give that to us. That's 45. The width is going to be the distance between your two octagons, which happens to be 2.8. So we take 45 times 2.8 to get a volume of 126 meters cubed. Now, number 8, also a polygonal prism. It happens to be a pentagonal prism. Let's fix that there. And it's the same one from your formula sheet. We're going to do area of the base, which in this case happens to be 125, times the width of your prism, which is going to be 6. It's the distance between your two parallel faces, your two pentagons. So we do area of the base 125 times the width, which is 6, to get a volume of 750 centimeters cubed. Now I did attach some practice for you guys to try. It's a good idea for you to try some of this independent practice on these problems as well. Now that you have these examples, again, feel free to go back and rewatch any of the parts of this video to review the formulas. The main formula you're going to use is area of the base times the width. But again, for a rectangular prism, just length times width times height should work just fine.